Okay, so 10/5 is base E and natural logarithms. So a natural base exponential function is an exponential function with the base of E. You're gonna say, what the heck is E, lady? Well, think about E kind of like how you would pi. It's a symbol that stands for a number, right? Kind of like pi. We can find him in your calculator. There is an E button in your calculator. In fact, there's two. So let's find him. The first place he's at is over here with the division sign. He's in blue. Okay? So let's just look at that guy. If I just put E in my calculator, so do blue and then division, and then push enter. Oh, I put him to do 4 decimal places. Hold on. 2.718281828. Okay? In fact, you can also think of him as pi. He is one of those irrational numbers that goes on forever. Okay? He may stop. I don't know. I haven't spent a whole lot of time with E. Okay? But think about him as pi. He's a symbol that stands for a number. The other place on your calculator is with this LN button. And we're going to talk about what that is here in just a second. So he's next to the 4. So if you do second LN, then you get E to an exponent. So you can give E an exponent if you'd like. Do you see how you can do that? So it kind of pops it in with the field, so he's already as a power. So if we want to do E to the first, E to the second, that sort of thing. Okay?
Wait, where's the LN button?
He's just to the left of 4. It looks like IN, but it's really an L.
Oh.
Yeah. So do second and then there you go. Okay. So, E is this symbol that stands for a number. So a natural logarithm is a logarithm with that base of E. So instead of writing it as log base E of x, we write it as the natural log of x. So that LN button in your calculator is a logarithm with a base of E. Crazy, right? And I don't know why they call it a natural logarithm and then they go ln. Le natural. Right? There you go. Okay, so let's try some things in our calculator. Like in number 1, it says use your calculator to evaluate each expression to 4 decimal places. Okay, here we go. Pop these guys in our calculator and just see what happens. E to the 0.5. Not bad, right? 1.6487. E to the negative 8. Ooh, what does that mean? Here's what my calculator gave me. Times 10 to the negative 4, right? Which means this guy has, I gotta move it over 4 times, so there's 3 zeros out front. So if I write this guy to 4 decimal places, he's just 0.0003. Okay, so then let's look at 2. This one says use your calculator to evaluate each of these expressions to 4 decimal places. The natural log of 3. Okay, so I'm just going to hit that LN button. 3. 1.0986. That means if I take E to the 1.0986, what number should I get about? 3, right? Thomas.
What number is Alan next to?
It should be next to your 4.
It's an actual button.
Yeah, the button. It should be below the log button. You see it now? Okay, so let's do another one. Natural log of 1/4. You could put in 0.5 if you don't want to put the fraction in, it doesn't matter. Negative 1.3863. Okay, these ones aren't on your notes, but I want you to try them. Try the natural log of 1. Zero. How does that work? Let's think about it for a second. Go ahead.
Oh, because it's e to 0.
Yeah, anything to the 0 power is 1. So this guy really is log base e of 1. So e to the 0 power would have to be 1. Okay, here, try another one. So when you put this one in your calculator, you probably want to do, oops, I hit the wrong button. What did you get there? 1. Okay, let's think about how that works. Why does that guy work? Okay, well this would be log base e of e. E to what exponent would give you e back? 1. Okay, so these are we're going to use these ones a lot. So make sure you got those ones. Definitely that one, for sure. Well, if a natural log is just a logarithm, then we can translate or rotate between exponential form and logarithmic form with them. Okay, so this guy right here in number 3 says, write an equivalent exponential or logarithmic function and remember that natural log of x is log base e of x. Okay, so e to the x equals 23. This is exponential form, right? How can I rewrite that in logarithmic form? Okay, well that means it would be log base e of 23 equals x. But instead of writing it log base e, he's natural log of 23 equals x. Sorry, my L's get cursive when I write natural logs. I don't know why. Do you guys know what this squiggly equals means? Roughly, about, right? Approximately. So it's not exact. They've truncated this decimal, so that's about, yeah. I just wanted to make sure you understood what that was. Okay, how about this guy? The natural log of x equals 1.2528. Okay, well remember that the natural log of x is log base e of x. So change forms. E to the 1.2528 is about x. Remember, we're just changing forms. Questions on any of that so far? Okay, remember that exponentials and logarithms are inverses of each other. Okay? Think back to when we just did our homework here on 10.5. These guys are exponentials. Would you agree with that? How did we undo them? We took a logarithm of them, right? So the same thing's going to happen here. E to the x and the natural log of x are inverses of each other. So they undo each other. Which means if I take e and I raise it to the natural log of x, that'll undo each other and it'll just equal x. Or if I take the natural log of e to the x, it will just equal x as well. Okay, so e raised to the natural log of 21. You can try it in your calculator, but do we have to? It'll undo each other, right? So what's that guy going to equal? 21. Okay, how about this one? The natural log of e raised to the, holy cats, x squared minus 1. I'm going to have to zoom in now.
It's just 1.
Close. It's your whole exponent.
What if it doesn't have the natural log?
What do you mean? What if it was like log base 10 of e or something like that?
Well, no, it has e to the ln 21. And then it has e x squared minus 1.
So if it just had this,
No, I mean, like, where'd the ln go?
oh, let me show you. Think about your rules, your log rules, right? When we had an exponent, he comes down out front, yeah? So this guy would be x squared minus 1 times the natural log of e. Go back up to this. That's okay. Go back up here to this purple box. What's the natural log of e? 1. So this guy would really be x squared minus 1 times 1. Good question. Okay. Ready to try solving some? Shiny smell. Okay, we're going to use the fact that they're inverses and they undo each other a ton. Okay? These are very similar to the ones that we just did yesterday. So, look at number 5 there. It says solve 3e to the negative 2x plus 4 equals 10. The first thing we have to do is get this e to whatever all by himself. So if I want to get that all by himself, what do I need to do first? Okay, let's subtract 4. So 10 minus 4 is 6. Why? Divide by 3. Awesome. Thank you. That 3 is a coefficient, so we're going to divide by 3. So now I have e to the negative 2x equals 2. Okay, so he was an exponential. He is an exponential. What undoes exponentials? The inverse. And what is the inverse? A log, a natural log, right? A natural log will undo an e. So I'm going to take the natural log of both sides. All right, our favorite come on down rule. This guy is negative 2x times the natural log of e equals the natural log of 2. All right, well, what do you remember about the natural log of e? It's 1, right? So this guy goes to 1, so I get negative 2x equals, and now I'm going to put natural log of 2 in my calculator. And now we can divide by -2, so x equals -0.3466. Should we see if it works if we plug it in? Let's do it. 3 times e to the -2 times -0.3466 plus 4. Hopefully we get close to 10. Whoop. Close enough for me. Okay, do you want to try 7? Go to 7. Let's do 7 first. Is the e by himself?
Yeah.
Yes. So what are you going to do?
Oh,
Logs of both sides. The natural log of both sides. Whoa, sorry. What do you have to remember to do? Flip your inequality sign. So you should get x is greater than or equal to negative 0.9730. Okay, so those two were in exponential form, just like the ones that were yesterday, right? The only thing that's different about this exponential form is that we see an e with it instead of some number like 5 or 62 or 16.3 or those ones, right? Okay. Questions on those?
So if there's ever e, we take the natural log and it's just a number, and we take the normal log.
Perfect. Yes, Harry. So if you see an e, you're going to take the natural log. If you see just a number, you could take the regular log. Now, technically, you could take the natural log of both of them and you'll still get the same thing because it's just a different base. So the ones yesterday, we could have taken natural logs of if we wanted to. Okay, but what's different then about 6? It has the natural log, right?
It doesn't have an e.
It doesn't have an e. So slap him with an e. Okay? So we're going to take it, and these guys are going to become our exponents. So I'm going to take it, and I'm going to say e raised to the natural log of 3x is equal to e to the 0.5. Remember, way back at the beginning when I said if the bases are the same, ignore them and play with your exponents. Okay, well those are my exponents. Now I'm going to give them each of the same base. And that's okay. Okay, what happens when I take e and I raise it to the natural log? They cancel out. So what's on the left side here? And e to the 0.5 I can do in my calculator. 1.6487. Solve for x by dividing by 3. So x equals 0.5496. These ones you still have to be mindful of because these ones are now in logarithmic form. So be careful with negatives on these guys. Does that make sense? Okay, that means if I plug this guy in, let's just try it. Then natural log of 3 times 0.45496 should be about 0.5. Yay, we got it. China.
So does that mean for problems like 6, the solution can't be negative?
Just be careful. So on this guy, he shouldn't be negative because when I plug a 3 times that guy, if he would have been negative, then we would say no solution. Does that make sense? Because 3 times that negative would have been negative, so we couldn't happen. Does that make yes, yes, yes? Because he's still a logarithm. Okay. So let's check your homework for this guy. The first one. You're throwing them in your calculator. So you're just going to find it to 4 decimal places, use your calculator, plug and chug. 5 through 8. You're just rewriting it. Let's do 5 together. E to the x equals 3. I want this written in logarithmic form. If you need to write it as log base e first, that's totally fine. I do it all the time. Okay, so this guy would be log base e of 3 equals x. But instead of writing it as log base e, how do we actually write it? ln. So this guy would be ln of 3 equals x. Why? So you don't actually have to solve it, just rewrite it. Yeah. Okay, so then let's do 7. The natural log of 15 equals x. This is logarithmic form. Let's go to exponential form. Remember, this means log base e of 15 equals x. Like I said, I still write it like this just so I can get it all squared away. So what would he be in exponential form? Yeah. Okay, then 9 through 12, these ones we're using our rules. Those should go super fast. E raised to a natural log is just, goes away. So number 9 is 3. Okay, those should go fast. So down at the bottom in 13 through, let's do 26 together because that one's a little different. 13 through 25, if you see an E, you're going to take the natural log of both sides. If you see a natural log, you're going to give it a base of E. So E raised to whatever you've got. But let's do 26. says the natural log of x plus the natural log of 2x is equal to 2. Ooh, what do you think? Careful, we've got a plus sign right there. How do I squish with pluses? I thought I heard it. Multiply, right? Multiplication. Nice job. So really, this guy means the natural log, our log rules still apply, of x times 2x. Or the natural log of 2x squared equals 2. Okay, so let's raise it to the e. We see a natural log. So this guy is going to be 2x squared equals e squared. Got it. got my calculator. E squared 7.3891 divided by 2. So x squared is 3.6945. Now what? Take the square root. Ooh, this is a good one. Is this one going to have the plus or the minus? Why not, Shayna? Yeah, it's in logarithmic form. So technically, we took the square root and we get a plus or a minus, but I can't take the logarithm of a negative number. So this guy just has the positive.